The APIsec Certified Expert, or ACE, will guide you through actively testing for API security flaws. This course is a self-paced, practical guide that will show you the tools and techniques that can be leveraged to attack web APIs. The ACE training will help you get your hands on the keyboard and walk you through the API hacking process. In this course, I will guide you through API discovery, interacting with endpoints, and exploiting several weaknesses like broken authentication, mass assignment, and broken object-level authorization. By the end of this course, you will have the skill set to thoroughly test web APIs. So who is this course for? I think ACE is great for anyone interested in testing APIs for security weaknesses. This course was meant to help improve the skills of bug bounty hunters, developers, and penetration testers. Before taking this course, it would help to have a basic understanding of how web apps and APIs work. The ACE course is completely free for anyone who wants to learn about API hacking. Those who would like to certify their knowledge can take the ACE exam. The ACE exam is a 6-hour practical assessment of your ability to test APIs and find vulnerabilities. Students who pass the exam will receive the ACE certification. How does this course work? Read, watch, and/or listen to the content provided over the course modules. It is highly recommended that you participate in hands-on labs, follow along with the course material, and complete the assessments at the end of every module. I hope you enjoy this course. Hello, my name is Corey Ball, and I'm the creator of the APIsec Certified Expert course. I'm the author of the No Starch Press book, Hacking APIs. In addition, I am also an evangelist for APIsec, as well as a senior manager of penetration testing over at Moss Adams. I have over 12 years of experience working in IT and cybersecurity across several industries. In addition to a bachelor's degree in English and philosophy from Sacramento State, I also hold several certifications including the OSCP, CCISO, and CISSP. I will be the instructor guiding you through this course. The ACE course will cover the following modules: lab setup, API discovery, endpoint analysis, vulnerability scanning, authentication attacks, exploiting authorization, testing for improper assets management, mass assignment, injection attacks, rate limit testing, and combining tools and techniques. In this course, we will be using Kali Linux as our operating system with tools like Postman, Burp Suite, WFuzz, and Kite Runner. You may use any operating system that you would like, but the tools and techniques of this course will be demonstrated using Kali. The tools that we will be using are all free, but because of this benefit, there are some limitations. For example, the free community edition of Burp Suite throttles scans to the point where it becomes unrealistic to use in a professional setting. So I do advise that you upgrade to professional and enterprise versions of applications when you move into that setting, but for the purpose of this course, you will be able to use the tools and techniques without paying for software upgrades.
Thanks for watching. I'm Dan Barahona, one of Corey's co-founders here at APIsec University. On this YouTube video, we're featuring the first 3 modules of Corey's API penetration testing course, including the introduction, lab setup, and API reconnaissance modules. You can find all 12 modules over at APIsecUniversity.com. The course is self-paced, hands-on, and completely free. And when you're done, you'll earn a certificate and badge to show your achievement. Now let's get back to the course.
All right, welcome to the setup. We're going to start here. We already have VMware Workstation 16 installed. I already have the Kali Linux VM downloaded. And now we're going to open the machine. And before we play this virtual machine, we're going to add some RAM and check out the network adapter. So we're going to switch this from NAT over to bridged. And we'll start it up. Here we can log in with the default credentials. Kali. And the first thing we're going to do is update our system. All right, next up we're going to check to make sure that Burp Suite is installed and up to date. This looks like the latest version available for me. While we're here, let's add an extension. We'll add AutoRise as an extension to Burp Suite. This should help us perform some automated authorization testing down the road. First, we need to install Jython. We can add that to this Python environment. And now we can install AutoRise. Great, looks like it's installed. Okay, next we're going to install Foxy Proxy in Firefox. Alternatively, when you're using Burp, there is the built-in browser that can be used for proxying traffic. We're going to use Foxy Proxy. That way we can easily proxy browser traffic to Burp Suite or to Postman. You can use Control-Shift-A to bring up the add-ons. And just do a quick search for Foxy Proxy. Here in the options, we'll set up our 2 proxies that we're going to be using. One for Burp Suite, which is port 8080. And we'll also add in the Postman proxy. Which is port 5555. Now when we go to use those, we'll have whatever traffic running through the browser, and you can just come up here to Foxy Proxy and then choose which of these that you'd like to proxy your traffic to. While we're here, let's set up the Burp Suite CA certificate, and we can do this by proxying our traffic over to Burp. And by going to HTTP Burp Suite. And we can grab the certificate from here. And now we're just going to add that certificate to Firefox. All right, we should be able to import our certificate here. Go ahead and check both of those boxes and hit OK. And now the certificate should be set up. Next up, we're going to be installing Postman. And we should be able to install Postman using, one second. All right, we should be able to install Postman with sudo wget https. Okay, and we're going to sudo tar that. And the final thing we're going to do with that is to link that to the command Postman. And if that was successful, we should be able to run Postman from the command line. May have made a mistake there, so we'll just want to remove user bin Postman. And we'll try that command again. I think I forgot to add the second postman the first time around. There we go. Now at this point, you can skip this and go directly to the app, but I do recommend creating a free account. That way you can save all of your Postman collections and the progress that you make throughout this course. And once you sign in, you should see something like this, and you can go to your workspace and create a workspace that's going to be associated with the rest of this course. So I've created this one here called ACE. And we can delete this for now because we will get to that later. All right, so we can see that Postman is up and running now. Next, we're just going to keep going down the list of installing the various tools that we will need throughout this course. And the next one up is going to be man-in-the-middle proxy to Swagger. I'm going to be putting my tools over in opt. Next we need git, docker, and this command should have installed Docker as well as Docker Compose. Sorry, this is git. We're going to be installing Docker. No, we're installing Docker now. What did we install? We installed Docker Compose. We also need to install Docker IO. Make sure we got that. Yep, that looks good. Docker Compose looks good. Let's get Golang installed. Okay, looks like a restart is required based on that update up there, so we're going to do a quick restart and continue installing tools. Before we proceed, let's update the default credentials. And then let's create a new user account. Or at least I will, for Happy Hacker. And we'll add Happy Hacker to the sudo group. And the final thing we're going to do is update the shell that's going to be used by Happy Hacker, and we'll go with ZSH. Actually, I don't think we set a password yet, so let's do that. Cool, looks like we got that working. And I'm just going to do a quick log out and log back in as Happy Hacker. And we'll go back to the opt folder and finish off our install of all the tools. Next up is the JWT tool, which we'll be using later on to attack JSON Web Tokens. This is the JSON Web Token Toolkit v2. And we can do a sudo git clone. And we just need to run Python to perform the installation. Next part is optional, but I want to be able to run this straight from the command line. And looks like that worked. Okay, now we'll go back and install Kite Runner. Okay, and Kite Runner is located or executed from the dist. And we can create a link for this one as well. Let's create that again. First, we're going to have to remove our current link. And let's give the full path to Kite Runner. That looks better. Next, we're going to install Arjun. And we should be able to set this up by running the setup file. And we won't need to link Arjun. It looks like it's already done that for us. And we should be good to go. The final instruction in this module is for setting up and installing Zap, just in case that isn't there. And wouldn't you know, in this case it isn't here. So we'll do a quick setup of Zap. Okay, so now we have Zap installed. We can open that really quick. While we're here, we can alter the add-ons so that OpenAPI is supported. Later on, we'll be performing scans, vulnerability scans using Zap of APIs. And here's this Open API support. We can update this, since that will be what we are focusing on. And should be good to go. Well, that does it for our setup. In the next video, I'll show you how to easily and quickly install your own lab filled with vulnerable apps. This course will mainly focus on crappy throughout the course content, and we'll have some exercises that involve VAPI
Hi again. Hope you're enjoying the first three modules of the API penetration testing course here on YouTube. Just a quick reminder that you can find the entire course with all 12 modules over at APIsecUniversity.com. You'll be able to take the quizzes, final assessment, and earn a certificate and badge for your achievement. Remember, go to APIsecUniversity.com and you can register for the course for free. I hope you enjoy it.
Throughout this course, we will be walking through two vulnerable applications, Crappy and Vappy. Both of these will be used to test out the tools and techniques that will be demonstrated throughout this course. APIsec has hosted an API hacking lab that you can use to practice your skills. Crappy can be found at http://crappy.apisec.ai. Vappy can be found at http://vappy.apisec.ai. If you would like to set up your own hacking lab, you can either host the vulnerable apps on your local host or on a separate system. Next is a demonstration of how to set up these apps on your local host. For the most part, during the course modules, we'll be focusing on testing Crappy. And then at the end of the modules, there will be additional assignments for you to attack Vappy. So first up here, we're going to create a new directory, and we're going to call it lab. And then we'll store Crappy and Vappy inside of that folder. By running these commands, we'll be able to pull down Crappy from the repository or wherever it's stored. And from here, once it finishes up, we'll use Docker Compose to install and run Crappy. Don't forget to run Docker Compose with sudo for that to work out. Once Docker Compose finishes up, then we should be able to test and see if Crappy is running. We can open up a browser and navigate to localhost, and port 8888 should be the main landing page of Crappy. So it's looking good there. And I believe 8025 is Mailhog, which is where There's a mail server essentially that will help you interact with the main application. So if there's a password reset over email or a VIN number that's emailed to your account, that'll be sent here. It's empty at this time because nothing's been set up, but it'll be good to know about this for later. Next up, we will install and download VAPI. We can move into the VAPI directory and should be able to run sudo docker compose up-d. Once that finishes, we should be able to try out the same thing by popping open a browser. And I believe this should just be located at port 80. And we could do a /VAPI. And VAPI seems to be up and running. To see the apps that we have running with Docker Compose, we can go back to the command line and use docker compose ps. And we want to use sudo with that, of course. And now we can see that VAPI is up and running. And if we want to stop that, we can run docker compose stop. Sudo docker compose stop. Now, outside of Crappy and VAPI, there are other labs that are out there. You can check out Try Hack Me or Hack the Box. Both of those platforms do have API-related apps, deliberately vulnerable, that you can go out and test your skills with. In addition to that, there are plenty of GitHub projects with vulnerable apps. Besides Crappy and VAPI, there's also Vampy, Pixie, REST API Go, Websheep, a whole bunch of them that are out there. So don't let your testing of the tools and techniques that you pick up in this course stop with these labs. You definitely want to get your hands on the keyboard and see what you can do with other labs that are out there. You will get the most out of this course by getting your hands on the keyboard and hacking APIs. After you've learned a new tool or technique, I highly recommend applying your skills to these other labs. In order to target APIs, you must first be able to find them. In this module, we will learn how to uncover the API attack surface of a target using passive and active reconnaissance techniques. How an API is meant to be consumed will determine how easily it can be found. Public APIs are meant to be easily found and are often advertised by the API provider. Public APIs may be entirely public without authentication or be meant for use by authenticated users. Authentication for public APIs primarily depends on the sensitivity of the data that is handled. If a public API only handles public information, then there is no need for authentication. In most other instances, authentication will be required. Public APIs are meant to be consumed by end users. In order to facilitate this, API providers share documentation that serves as an instruction manual for a given API. This documentation should be end-user friendly and relatively straightforward to find. Partner APIs are intended to be used exclusively by partners of the provider. These might be harder to find if you are not a partner. Partner APIs may be documented, but documentation is often limited to the partner. Private APIs are intended for use privately within an organization. These APIs are often documented less than partner APIs, if at all, and if any documentation exists, it is even harder to find. In all instances where API documentation is unavailable, you will need to learn how to reverse engineer API requests. We will cover reverse engineering later in a separate module. For now, we will focus on detecting APIs and using them as described within discovered documentation. APIs meant for public consumer use are meant to be easily discovered. Typically, the API provider will market their API to developers who want to be consumers. So, it will often be very easy to find APIs just by using the web application as an end user. The goal here is to find APIs to attack, and this can be accomplished by discovering the API itself or the API documentation. If you can find the target's API and documentation as an end user, then mission accomplished, you have successfully discovered an API. Another way to find an API provided by a target is to look through the target's landing page. Look through a landing page for links to an API or development portal. When searching for APIs, there are several signs that will indicate that you have discovered the existence of a web API. Be on the lookout for obvious URL naming schemes like targetname.com/API/v1 or api.targetname.com/v1. Another indicator of web APIs is the HTTP request and response headers. The use of JSON or XML can be good indicators that you've discovered an API. HTTP request and response headers containing content type, application JSON, or application XML can be indicators that you've discovered an API. Also watch out for HTTP response bodies that include statements like curly bracket message, missing authorization token, curly bracket. One of the most obvious indicators of an API would be through information gathered by using third-party sources. Check out GitHub, Postman, Explore, and Programmable Web's API directory. When searching for a target's APIs, use the target's web application as it was designed. Use a web browser, go to the web application, and see if an API is advertised. Once you have an idea of how the web app functions, dig deeper by deploying passive and active reconnaissance techniques. Passive API discovery is the act of obtaining information about a target without directly interacting with that target's systems. When you take this approach, your goal is to find and document public information about your target's attack surface. Typically, passive reconnaissance leverages open source intelligence, or OSINT, which is data collected from publicly available sources. You'll be on the hunt for API endpoints, exposed credentials, version information, API documentation, and information about the API's business purpose. Any discovered API endpoints will become your targets later during active reconnaissance. Credential-related information will help you test as an authenticated user, or better, as an administrator. Version information will help you test for potential improper assets management vulnerabilities. API documentation will tell you exactly how to test the target API. Finally, discovering the API's business purpose can provide you with insight into potential business logic flaws. As you are collecting OSINT, it is entirely possible that you'll stumble upon a critical data exposure, such as API keys, credentials, JSON web tokens, and other secrets that would lead to an instant win. Other high-risk findings would include leaked PII or sensitive user data, such as social security numbers, full names, email addresses, and credit card information. These sorts of findings should be documented and reported immediately because they present a valid critical weakness. Next, we will check out a few tools that you can use for passive recon, including Google Dorking, Git Dorking, API directories, the Wayback Machine, and Shodan. All right, so now I'm going to go over a few techniques that you can use to Google Dork for APIs. But before we do, the thing that you want to try is to just Google for information about the APIs. Nothing too complicated, just straight up searching for it. Because if your target has a public API, more than likely they're advertising it. It's not hidden, it's not hard to find. They want you to find it. And you can just simply Google for, we'll even say Google API. And see what options we get. So we get the Google API console. There are a few APIs that Google's putting out there that are advertised. So once you're done doing some basic searches like this for information, maybe Google API, maybe your target name, docs or developers or GraphQL, anything like that. If you're trying to find what advertised APIs are out there. But once you want to get into Google dorking, then you can use some search terms like in title, API, and we can target a specific site like Coinbase.com. And right away you can see the Commerce API for Coinbase can be found with a term like this. Some help about how to create an API key for Coinbase Pro, and more information about the API documentation. So you can see the results here are pretty slim. If we go back, ton of results for this, but they are filtered to the top. Whereas with some Google dorking, we get far fewer results that can be helpful for finding your target's APIs. We can do another search parameter in URL, and we're going to specifically search for a piece of the URL path here. So we can specify API v1, v2, v3, and this time around we'll target Microsoft.com. And here we can see this deprecated use the Outlook REST API. So we can check that out. And it's some information about a deprecated API. This is one of those situations where versioning information has been shared with us, so we could focus on testing for something like this later on for improper assets management vulnerabilities. And the next one, we can go back to trying an in title and specifying JSON. And we'll just try another target eBay. And here we see some developer pages for eBay. More often than not, these are going to be forums that are just talking about how to use the API, how to use XML or JSON or the JSON API. Yeah, any forum information on your target is going to be helpful. Other people experiencing issues with using the API, anything like that is going to help you be able to use it. So you can use a few different search parameters for Google dorking that'll help you. If your target's just advertising their API, a quick search is going to lead you in the right direction. After Google dorking, you can start Git dorking. And so regardless of whether your target performs its own development, it's always worth checking out GitHub for sensitive information disclosure. Developers use GitHub to collaborate on software projects. Searching GitHub for OSINT could reveal your target's API capabilities, documentation, secrets, such as API keys, passwords, tokens, which can be useful during an attack. We can begin by going over to GitHub. And similarly, you can just search on GitHub for just your target's name to see what comes up. We'll just go. Okay, and so we can, just search Coinbase API, see what comes up. A client for using Coinbase Pro API, deprecated Coinbase API, PHP wrapper for Coinbase. Different projects that could be useful. The other thing you can do is look for issues. So maybe go into the Issues tab, And this would tell us, if someone accidentally exposed their Coinbase API key, someone else may have spotted it and brought up an issue, and that issue may still exist. And so, just to give you an example of that, yeah, here's a good one. So, API keys exposed. Someone else that was trying to help out. Don't use your API key. Use an environmental variable instead. And we can look into this to see exactly where it's exposed, to see if the issue's been addressed, so on and so forth. Yeah, sometimes like this, it'll just be called out right away. So client ID is here. You left your API keys exposed. And you can see a bunch of these. And with this many, with 85,000, toss in your target's name and see if there are exposed API keys specific to your target. Beyond some basic searches like this, we can also use some parameters like extension. And we'll look for JSON and target someone else. We'll do NASA. And this should give us extensions that include JSON in it. Okay, we're still in issues. There's the problem. And NASA, for example, they have a public API, so it's something that's going to be advertised out there. But a page like this is really going to help you out during discovery. If you knew exactly how your target named their API keys or something like that, then you can search for those exact terms. So this one is specific to how Shodan names its API keys, and so we could do another search like this and see. Then you can see right here, someone has built a tool that will search GitHub for public Shodan API keys, likely using a search term like this. And typical flow, go into the actual repos. For something like this, you may have better luck looking for issues. In a previous comment, you have attached a screenshot in which your Clearbit API key and Shodan API key are both visible. Make sure that you remove it. So even though it's not actually in the code, which means it's not going to be searchable, it's in the screenshot, and someone else calling it out has made it searchable for us. You can also search for common headers. So one of the most common headers for API authorization is going to be authorization bearer. And then you can specify a target after this and see what's out there. Yep, and something like this looks like an exposed key, but there's also, testing in it. So if this was specific to your target, it would definitely be worth looking into. The final one, when organizations create a Swagger file, oftentimes that'll be named swagger.json by default. and we could see what's listed. And we'll probably get better results from authenticating, so you probably want to start with that. Okay, now that we're authenticated, we can see what's under code. All right. And here you can see several instances where Swagger files are available. And this would just simplify your efforts to be able to import something like this into Postman and then have the instruction guide for using the API imported to easily test it. Pretty useful. Next up, we're going to show off Shodan. Shodan, as you can see right here, search engine for everything on the internet. Shodan performs regular scans of the internet and has them available here for searching the results from those scans, which in our case, while we're looking for APIs, we're going to be looking for any responses related to HTTP, anything that's going to show us that an API is available, maybe headers like application XML or application JSON. Those sorts of things are going to help us discover some APIs. So you can, very similar to Google and GitHub, we can just use some generic search terms first. So I don't know if we can find anything just by searching for Coinbase. And you can see just from a generic search, we're getting some results. If we wanted to look through the results for open ports, of course, we're going to search for 80 and 443. And to use a lot of the Shodan features, you'll want to be logged in as an authenticated user. So I'll do that really quick. Okay, now that we're authenticated, we can go back to our search. And we can specify a port. And if you have a specific target, then you would just filter through these results to find a URL related to your target. Another header that we've talked about already, content type application JSON. This is often used with APIs, and if you paired this search with your target's name, that could help you quickly find an API related to your target. But with this generic search, we're getting over 4 million results. So searching by your target would help narrow that down a bit. And you can see here the common name that was used included APIs right in the URL. Right here, issued to you. Okay, so in the SSL certificate, shows you who it's issued to, and likely related to the AWS API. If your target has WordPress, the WordPress API is WP-JSON. So using a search term like this will help find all of those instances. There is a information disclosure with the WordPress API, and you can actually just see this URL leading to it. So WP-JSON, WP-v2 users, normally that request, if it's not blocked, will reveal all the users involved with WordPress. So if you find out that your target has WordPress in use, then you can just specify WP-JSON and then search for your target name here. Next, we're going to check out the Wayback Machine, but to do that, first we're going to want to find the Reddit API docs, just as an example. And this is the current overview of the Reddit API. So the Wayback Machine is an archive of the internet, and it keeps snapshots of changes made to different websites. So we can go onto the Wayback Machine and search for that exact URL to see if there's a history with it. And what we're looking for here is major changes that have been made to the API over time, or the API documentation over time. And as you can see, since 2012, there have been a ton of changes here that are documented. And so if we just go back a few years and check out one of these snapshots, this will give us a view into the past of maybe endpoints that are no longer supported. And so the cool thing you could do here, especially with improper assets management vulnerabilities, is look for endpoints that used to exist but may not exist anymore. And then when you're performing your attack of the API, then you can attempt to search for some of the endpoints. And I'll put them side by side so we can see those differences clearly. And here they are side by side. On the left you have the current documentation, and on the right you have the documentation from a few years back, February 9, 2016. And so just comparing them side by side, we can see some differences right away. CAPTCHA is quite a bit different. Flare isn't up here, so maybe collections is a whole new section. We can also see some differences in the requests made to account. So yeah, pretty cool way of seeing historical documentation. And essentially, if Reddit didn't, just get rid of, if Reddit didn't update their API to block these dated URLs, if they just updated their documentation, then we'll be able to use this outdated documentation to be able to find URLs that may not be supported and have vulnerabilities present. It's a really cool way of making that process a bit easier. In this module, we covered some basic techniques that can be deployed to gather information about your target's API attack surface. The first step to hacking a target's APIs is to uncover as much information about them as possible. Using these reconnaissance techniques can not only help you discover the existence of APIs, but can also lead to critical vulnerability findings. Next, we'll focus on active recon. Active reconnaissance is the process of interacting directly with the target primarily through the use of scanning. We'll use our recon to search for our target's APIs and any other useful information. During this process, you will be scanning systems, enumerating open ports, and finding ports that have services using HTTP. Once you have found these systems, you can open a web browser and investigate the web application. You could find an API being advertised to end users, or you may have to dig deeper. Finally, you can scan the web app for API-related directories. Essentially, you'll be building out your target's API attack surface directly from your target. During active recon, we'll be using tools like Nmap, OWASP-AMASK, GoBuster, KiteRunner, and DevTools. Alright, since we're moving into active reconnaissance, we will want to stand up our own lab. That way we're only testing targets that we're authorized to scan and test. And once Crappy is up and running, we'll test it with a browser quickly to make sure that it's working properly. And we'll move into running our Nmap scans. Okay, now that that's finished, let's pop open a browser and do a quick check. Cool. Looks like it is up and running. So now we'll move into performing an Nmap scan of our local host. We'll use default scripts and service enumeration. You can also use dash lowercase o, uppercase a to have the scan output into different formats. And so with that first scan, we are seeing port 8888 open. The service is HTTP, and it's an open REST web app server. So it's all good information. Next up, I would run an all port scan just to see if there's anything else running locally or for our target. And sure enough, 8025, 8888, and 44665. Specifically 8025, we can get more information about that by doing service enumeration for port 8025 and get really quick results specific to that. But this is going to be the Mailhog server hosted by Crappy. And we'll be using that for a lot of that vehicle verification process and email resets and that sort of thing. A natural next step from here would be to visit the web server. And since we just did that with Crappy, I'll do it with Mailhog. So you can see that. And this is what Mailhog looks like. And yeah, from there you could explore it as it was intended. Not really moving into any attacks or anything, but just checking it out and seeing what it's all about. But we're not going to get caught up in that now. We're going to move on to our next tool, which is going to be AMASK. Okay, so AMASK is a command line tool that can map a target's external network by collecting OSINT from over 55 different sources. You'll notice that I've included it in the active section, but AMASK does have options to be either active or passive. You can set it to perform those scans just by using its dash passive or dash active. If you choose the active option, AMASK will collect information directly from the target by requesting its certificate information. Otherwise, it collects data from search engines like Google, Bing, HackerOne, It also uses SSL certificate sources such as Google CT, Census, Facebook CT. It also uses search APIs from Shodan, Alien Vault, Cloudflare, and GitHub. It also uses the Web Archive Wayback. So to make the most of a mass, you want to populate the sources found here. And so by default, a mass is an awesome, powerful tool. But to make the most of it, you can use this command to see which services you can connect to a mass by creating accounts, getting API keys from those free accounts, and then plugging them into a mass. And you can see list has quite a few options. And so you can go into as many of these as you'd like. Not all of them are free, some are paid, but you can go into a lot of the free ones and get API keys that you can then plug into a mass. And if you'd like to set up an example API key, you can check out the course documentation for this section, where I go in and create an account in Census and then plug in that information gathered from the Census free API key into the mass config. For now, we're just going to move on to performing a search with a mass, and we can do that with a mass enum active d. For target name, because this is going to perform some, it's going to be both active and it's going to search through internet sources. Of course, anything we're hosting in our private lab isn't going to reflect that. So APIsec has hosted Crappy for us. So we can check out what this comes back with. You can just do this scan, or you can pipe grep and a term like API or something like that to the end of it. Since Crappy has API in it, APIsec has API in it, we're not going to get the greatest results by doing that. So we'll just let this run. So we didn't get the best results from crappy.apisec.ai, but we can choose another target that allows for external penetration testing, something like Microsoft.com. And with this, we would get a ton of results. So let's actually use that pipe on this one for grepping API. As you can see from the results, a lot of good options for targeting Microsoft. Many of these, start with subdomain of API. Interesting ones to check out. Let's see, anything that looks legacy or maybe not supported. Something like Sandbox or UAT or testing. Those would be interesting finds. Of course, Sandbox in this case with Microsoft, probably a legit URL to visit that is supported by Microsoft. But those would be things to look at. And once you get these, then again, you can explore those with a browser. Go check them out for more information. Now that we have an idea of a few URLs that we could go after, or we already have the IP address, we already have the ports, we can perform a directory brute force with GoBuster. Oh, it looks like we'll need to install GoBuster. Oops. Cool. So with GoBuster, we can perform a directory brute force. We can supply the target address. and we'll supply a word list to use. Oh, and instead, let's see, I forgot to add HTTP. Okay, so in this case, it looks like Crappy is likely responding with the same error status code for a variety of responses. So we'll just add the wildcard option to that, and then we can see, you know, everything looks like it's responding with 200. So we can filter out 200 to see what sort of interesting responses we get. And sure enough, we see some of these endpoints here: community, identity, workshop. And we can stop this here. If we want to learn more about any of those specifically, we can stop our scan and search. We'll try out community first. Okay, now we have a different problem here. Instead of 200, we're just getting 404. So let's remove this and see what happens. To speed up your scan, you could use a smaller word list, one that's API specific, and it'll have various paths like /API, /v1, /docs, /dev, you know, things that are very typical, /rest, things that are very typical for APIs to have in the path. For this, we're using a pretty large word list against it, and Crappy does have a unique way that it has the paths formatted. So, may not get the best results with an API-specific list for Crappy, but you can use your GoBuster results to explore some of these options. So that was for community. We could also check out I believe, let's see, identity. Okay, we need to go back to the wildcard, and 401, it needs to be called out. Not getting much here. Let's try, I think the other one, workshop. So the thing with GoBuster is that it's going through logically with the path that we provided. So right now it's trying workshop / words in the word list. So as you can see, we just got admin, which is a great find. But we're not finding too many things API related. Using an API specific list could help with that. But using another tool that was built to search specifically for APIs is another option, and that tool would be KiteRunner. So GoBuster is great for quick directory brute force, finding some of these non-API related directories like admin, which is a good find. But KiteRunner was developed specifically as an API discovery scanner. And so it has word lists and searching techniques that are specific to how APIs work. For example, GoBuster is just going down the list, right? So workshop /admin, and then it's going to try a different word. But if it got a 404 response from /API, then GoBuster isn't trying the next iteration beyond that. It's stopping and saying, that probably doesn't exist. Whereas Kite Runner, as we'll see here in a minute, will search beyond that because it's built in with the logic that REST APIs use requests like /API/v1/users with some resource ID beyond that to specify users. And if an API provider has a unique response for that request, even if it's gibberish for the resource ID, then Kite Runner is going to flag that and show that there's likely an existing API request or endpoint that you can work with. All right, the next tool that we can use is DevTools. And so if we pop open a browser, navigate to Crappy, and hit F12, we're going to see the DevTools pop up. You can go over to Network and hit Control-R to reload the page. And here you can see several of the sources that are being used for this page. We can navigate around, hit Control-R, see what we get. Create a test account. And log in with your test account. And now once we're on the web app, in the graphical interface, we don't see an API advertised anywhere. But as we navigate around, you can notice that some API calls are being made, more or less beyond the GUI. And to help us spot this, we can add the URL here, and you can see that we do have some API endpoints in use here. API v2 community, API shop products. And at this point, we know that we've discovered some APIs. If we want to see more about this, we can select one of our requests, and let's expand this so we can see it better. Few things that we can see. This is the GET request to API shop products. In the headers, we do see that content type application JSON, OpenResty web server like we saw in our Nmap results. And another interesting thing we can see down below in the request headers is an authorization bearer token. And we'll learn more about this token specifically in an upcoming module. Another cool thing I wanted to show off while we're here is that you can right-click on a specific request. So if you found an API request that was interesting to you, maybe you wanted to interact with it more in Postman, we can copy this as a curl request and then pop open Postman. And Postman has a cool feature where it will let you import a request from curl. So you can go import raw text, and then you can just paste that curl request here. And it will build out the request exactly as it was, including your bearer token. And then you can interact with it by sending that API request over and seeing how the API provider responds. And we're seeing a lot of that information that is being featured in the GUI. So the available balance, the product name, and the price of those, you can see that that's all populated by this API request. And so the product has an ID of 1, it has the name of the product, the price of the product, and even the image. And down below, we can also see that there's this credit here of 100, which is going to be reflected in our available balance. It's a pretty cool way of investigating a single request. In an upcoming module, we'll actually go over reverse engineering an API. And so instead of working with a single request, we'll navigate through the entire web application, check out as many buttons and features as we can. We'll intercept and proxy that traffic, and we'll be able to turn that into a Swagger file. So that'll be in the one of the next few modules coming up. Reconnaissance is extremely important when testing APIs. Discovering API endpoints is a necessary first step when attacking an API. Good recon also has the added benefit of potentially providing you with the keys to the castle in the form of API keys, passwords, tokens, and other useful information disclosures. In the next module, we'll perform endpoint analysis, and we'll begin interacting with the API and searching for excessive data exposure. In addition, we'll learn how to use API documentation and how to reverse engineer an API.